Project 7.1. Okay, Project 7.1 is about state machines and the serial adder. So, um, basically, this assignment project didn't actually give you any instructions on what it didn't instruct you to do anything. Pretty much, it just walks you through how to use a state diagram to keep track of states and transitions, and then how to basically break down a situation that you want to code and draw a diagram that helps you code it. So, using state machines, you can behaviorally describe a circuit if you know the way it's supposed to function. Okay, so going through it, it says that you're just supposed to start with the simplest state. So where f is, let's say f is the sum and cout is the carry. And 0, 0 would be the most simple state, and it makes sense to start with that because you don't have, well, it's just simple. So anyway, what I did is I just read through this, and it all made sense to me. It's saying, okay, well, if you're in this state, and if A and B is your input, okay, it took me a second to figure that out, what A and B was. A and B is literally, it's just an adder circuit, so basically A and B are the two digits being added together. And if there's 0, 0 and F is 0 and cout, pretty much F doesn't matter. It doesn't matter what F is when you're doing the addition to figure out what cout would be. But if you actually go in and you do the addition, I did it on a couple of them. If you actually do the addition on the side, you can figure out what your next state's supposed to be. So here it's just saying if you had an f of 1, I'll just go down. Basically, it goes through the whole thing. It says this is define your next state. Here, if it's 0, 0, your state doesn't change, so you draw the transition back to that state there. 0 and 0 with a carry out of 0 would generate another 0, 0 state. So that's why you have it drawing back on itself. If A or B were 1, you'd have a sum of 1 and a carry out of 0, which is a different state because these aren't the same numbers. So you draw a new state and you draw the transition with the A XOR B, showing that those are the inputs that would cause you to change to a different state. Okay, so basically you go through that, you go through each and every case of your inputs, and then you draw the transitions. So you do that to there, and then you do this one to here. You say, well, what if they are both 1? Okay, if they're both 1, then you get a carry out of 1 and a sum of 0, which is a different state. So you call that S2. Okay, then you would start on another state, because that's all the possibilities from S0, A, B, or A and B, not A and B, or A, X or B. Those are the only different combinations of inputs you could have. So then you go to the next state and do the same thing. Okay. And you basically can just do the computations and figure out what it would be, and then draw the arrows, the transitions of what those inputs would lead to, what state it would lead to. So I actually did that here on a couple of them. So I said, okay, well, if A or B is like this, where A is 0 and B is 1, or A is 1 and B is 0, then you get this situation here where you have the carry out of 1 is here, because it's given here, and 1 plus 0 plus 1, where this is A and B, would give you a 0 and a 1 out. I get so which is what you have here, 0 and a 1, so it goes back on itself, to transition to itself. Okay, now what if you did this? So basically you do that for all those cases, and I drew it better down here. Here I actually drew it out a little bit better with different colors and stuff. Okay, so if you see, here we go. Do one where it goes to a different state where there's a transition. Okay, so if not A and not B would be 0 and 0. Not A and not B, okay, 0 and 0, and the carry out is the 1 in this state. So and we don't care what the F is. It doesn't affect the situation. The previous F doesn't really come into play here. But if the carry out from the previous stage was 1, then that is the carry in this stage. So the carry in would be 1 plus 0 and 0 would be 1 with the carry. Okay, so F of 1 with a carry of 0 is state S1. So you draw a transition to state S1. Basically go through all the states, and you do each possible combination and figure out what state it would go to. And you draw this map out, this state machine diagram. And then this talks about the flow of actually coding it, and it talks about there being 3 stages: the next state decoding logic, the state registers, which hold the values, and the output logic. So, and it says that for simple, we don't need mealy inputs, and that is our situation in this project. And I wrote some other notes here about there being sequential logic, because it's you got the feedback loop, and here, so then it goes through it walks you through the actual code. So here's the module for the serial adder, and then here's the different states. They're stored as constant variables, and here are here's one second. Okay, here are the actual variables that hold the values of our present state and next state, and basically there's 4 states. Let's see, what did I write here? I wrote 4 states. Okay, well, there's more than that's actually not right. So there's a F1 and F. There's like a previous F and a previous C out, and that's what should be stored. Oh, each one can store 4. Each one can store 4 states. What I wrote here, 2 plus 2, doesn't actually make sense, but these were just notes that I put on here. So this can be any combination of 0s and 1s, right? So this would represent 4 states. This can also represent 4 states, but this is the next state. This is the previous state, and so you just have these 2 serial buses, arrays. Okay, I'm running out of time here. Let's see. So it says the block will drive the next state. So it talks about the always block. So it says that the always block has, we look at the previous state to determine the next state, which is exactly what we did in the state machine diagram. And we look at A and B, where those are our inputs. So basically A and B are our inputs. These would be the array. 0, 1, and 1 would be here, 1 and 1, and then we'd say, well, what does the transition go to? What is the transition? Where does the arrow? So 1 and 1, if the inputs A and B were 0 and 0, it would go to S1. Okay, so basically that gives us the diagram that we need to write this code here, and that's what it talks about. Then it talks about the state registers here, storing the information into flip-flops. And then it says that we don't need any mealy inputs in this project, and then the final output logic is given here as well. So pretty much this project just walks you through the implementation of the code and tells you how to come up with the state machine diagram to help you cut the actual circuit. And that's it. It doesn't ask you to do anything after that. It says this is what it looks like all together, and that's the end of it.